All right. In this one, we're going to talk about periodic trends. So the first trend usually has to do with size. And actually, for size, you need something else. So this effective nuclear charge. So it's kind of annoying here. It starts with electronegativity, but nonetheless, um, it'll be one that you'll need to learn in that trend. And so then periodic electronegativity increases towards fluorine. So the closer you are to fluorine, the more electronegative. So, um, so something like that. It's misleading because it seems to be that the noble gases, but no, it peaks because this is a measure of electron bullying. And since the noble gases don't form bonds, they're not bullies for electrons. So peaks at fluorine. The next one is ionization energy. And so we have the kind of trend that increases as we go across the periodic table, and then it decreases as we go down. So um, the increasing ionization energy. And the thing is, ionization energy, though, you have the bulk trends of it, but then you have these dips. And these dips to me are actually very important. These are the fine details that really support that quantum mechanics is real. And so we have that difference between going from S to P, and then we go from difference between having P all unpaired electrons to start pairing it. So to me, this is a big deal picking up on it. So overall trend. So if you're asking about a jump of two over, then you don't see that. But if you see a jump of one, wonder, is it going from S to P and is it going from P3 to P4? Then we have this kind of unexpected dip, right? Or expected because of our hard knowledge. So again, overall trend, but then the fine detail of it. The last one in here is electron affinity. And so uh, it's the opposite of ionization energy. So the two ways we do reactions is gaining and losing electron. So an electron affinity is gaining an electron. And so it's the amount of energy released from it. And so these want to gain it, so they have the biggest effect of that. So lastly, we have the atomic radius, and that's where we need that Z effective. And so when we go down, it gets bigger, but everybody, this is the most common one, they want to say it gets bigger because there's more electrons, but it doesn't because of this Z effective trend. All right. And so oddly, they don't put it there, they put it in this other one. And so you can look this up if you want to look at it in more detail, but effectively, what it's saying is that the core electrons are shielding. And so as we move across the periodic table then and we add protons, then they're being shielded by those core electrons. And so what we see then is the Z effective increases, and that's what shrinks it. So it's a little tricky. You'll have to read it in more detail. So understanding how Z effective changes, I focus more on the horizontal row, not going down because we don't need it going down, but that does have that overall trend going down too.